Hello. All right, so what's an antiderivative? Tonight's homework, page 294, multiples of 5. Let's talk. You're going to tell me how to do this. I know nothing.
I know how to do it. Oh, yeah.
Wait, if we do these homeworks, can they count for next quarter?
No, this is still, if you're doing homework checkies this week, it's still this quarter. Yeah. All right. Okay, yes? I didn't even ask the question yet. Okay. All right.
Can this calculator derive?
It can, and it must, and it will. But we're doing it the easy way first. We're doing it with our own heads. All right, so here's the game. I'm going to give you, like, the answer to a derivative problem. This is sort of like Jeopardy, right? They give you the answers, you give me the question, right? So what was the question? This is how you got to think about this. So if I give you f prime, what was f? So I had an f, I took the derivative, I'm hiding that, you got to tell me what it was. Okay. All right, so sine, you know this, right? The derivative of sine is cosine. Okay. So the antiderivative of cosine is sine, as simple as that. That little s squiggle thing, right? If you go the integral of sine, cosine, sorry, get a little carried away. The integral of cosine is sine. That's what I'm saying. What's this plus c stuff?
It's a constant. They have like a number.
Right, because it could be right. So how do you check an antiderivative? If you differentiate it, you should get back the integrand, right? If it differentiates sine, I get cosine. If it differentiates a constant, I get 0. There could have been something there, I don't know, plus 2. Who knows? Something, right? Yeah. Okay. Go away. Go away. Go away. No more away. Okay. All right. All right, so let's see who's on the ball here.
Okay.
Eduardo's not allowed to answer.
Damn.
You know it, right? Yes.
Don't ever let him answer.
Don't let. No, you're not allowed to answer.
Oh,
For 5 minutes.
I
Okay.
got.
Yeah.
Okay. Half sine 2x plus c.
Sine of 2x plus c over 2.
Yeah.
Why?
Because you gotta multiply.
Because to check it, you differentiate, right? The derivative of your answer should be cosine of 2x. Is it? Yeah, because it's a chain rule problem. How do you differentiate sine of stuff? Cosine of stuff times the derivative of the stuff. What's the derivative of the 2x? 2. So if I just said sine of 2x, it would be off by a factor of 2. So divide it away, little fudge factor. Yeah. Oh, goody.
And realist has to go today. You can find out on Saturday. Wednesday. They go up on Friday. It's not the day before. She usually puts it up after school. So.
Alrighty. So that was hard.
You see it.
All right, how about this one? What do you say the antiderivative is? Or what I differentiated to get that? X to the third plus the constant. Don't forget the plus c's. Oh, there's a whole song about that. Do you remember that song last year about the plus c? No.
It's behind me.
He's just a constant. Nobody loves it. Right? Okay. All right, we'll get to that. All right. There's a song for everything. Alrighty. Let's continue. Let's try this again. All right, again, the game is I give you f prime, and you got to guess f.
Wait, don't say anything out
No,
loud.
don't say anything. Valerie's busy cogitating. That's a good thing. Those SAT words. Cogitate. No? Nobody knows cogitate. In the context, hopefully. Valerie does this all the time.
Is it 1?
Think a lot, yeah. What?
Is it 1/4 x to the 1/2?
1/4 x to the, let's see, 1/4 x to the 1/2. Like that?
Yeah.
Well, let's check it. To differentiate x to the 1/2, you get 1/2 x to the negative 1/2. That's good. But the 4?
Yes, the 4.
Okay, so isn't the rule that you multiply by 1/2?
Rule Shmuel. I don't know. I don't got no rule. I don't got no rule.
Yeah.
Where'd the 4 come from? If you differentiate x to the 1/2, you get 1/2. Okay. X to the negative 1/2. Okay. walk away. You're done. That's it.
You have to multiply by the new exponent.
No,
Yeah,
no, no.
So you just proved the rule wrong.
There is no rule. What rule?
There is a rule.
I never gave you no rule.
But I know a rule.
No, you lie. No rule. No, that's right. X to the 1/2 is good. Okay. Alrighty then.
Keep going.
Let's go.
Are you going to come back to this and tell me why the rule doesn't
We'll get to that. Yeah. The rule you're quoting works, but you're quoting it wrongly. You chose unwisely. Sorry, reference. He chose unwisely. Huh? Negative x to the negative 1 plus c. Is that right?
Yeah.
We'll try it. Let's see. Do the power rule for derivatives here. Negative 1 goes in front, becomes positive 1, right? X to the negative 2. Yeah, there you go. Done. Okay, good. Thanks. Just doing the power rule backwards, right? Okay. All right. 10x. 5x squared plus alpha. I'm tired of C. Doesn't have to be C all the time. Some constant. Huh?
That looks like a 2.
It does, doesn't it? It's supposed to. Actually, it's supposed to look like an X. Why is this so washed out? I can't even see what I'm doing. I just washed out this whole screen, Connor. I can't even see what I'm doing over there. Can you see the scroll bar? I can't see it. We're trying to make it a little brighter. The screen, it's not working well.
You didn't actually do this?
It made it too bright. Alrighty. So, how about this?
Don't say the answer.
I did!
No, but Anisha is, and we all know he knows.
Alright, don't call out. Raise your hand. I'll call on somebody. Ronnie.
5x squared minus 2x.
5x squared minus 2x plus beta? No, the derivative of negative 2x is not negative x squared. What is wrong with you? Yeah, who's next? Who's the hand?
1/3 x to the 3rd.
Oh, so you're quoting the rule correctly.
Yes.
Yeah, but the rule Shmuel. I don't have any rule.
Yeah, Blake. Yeah, Blake.
Right, the derivative of x cubed is 3x squared, but I don't want that 3 in front, so fudge factor divide by 3. Fix it. Right? Okay. Fudge factor. It's a little fudge. That 3 down there? That's a little fudge factor. Right, because x cubed isn't good enough, right? All right, how about this?
Oh, I know what I did wrong.
I know what you did.
I didn't do the rule wrong. I just didn't divide by the
Okay.
thing I multiplied.
Right, exactly. Good, see? That's why I didn't tell you. Once you figure it out. All right, so clearly you know the first 2 terms of the answer. Now what?
I got it. 5x.
All right, 5x squared. Go ahead.
5x squared minus x to the 3rd over 3.
Plus 2x.
Plus 2x plus, oh, I don't know, gamma. Huh? Okay. Any questions how that works? Is this awful? This is easy. If you know your derivatives, this is easy. All right, let's try some more.
It gets awful.
You got to know your derivatives. It's always spent forever on
You just know
derivatives.
the rule.
Yeah, but there are a lot of different rules. Okay, so f prime is given. What is f?
Let's do harder ones.
2x to 3 halves. Let's see.
What do I have to do? Delta. Does that work? No? Why not?
Yes. It's 2 over 3.
2 over 3? Let's see. If we differentiate x to the 3 halves, you get 3 halves times 2 is 3. X to the 1 half when you subtract the 1. So there's a 3 in front that I don't want. So fix it.
Yeah, it's
Okay. Hands. Any hands? Anybody? Hands. No. 1 hand out of 30? 29, 28, whatever it is. What are we up to? 29?
Negative 2 cos 3x.
Wait, can you explain that one?
Well, if you differentiate the cosine of stuff, you get negative sine of stuff. But, so this negative goes away. And the derivative of stuff is 3 times the 2 is 6.
I get why that's right, but how did you know
Yeah,
that?
how did you,
Very carefully.
Go,
Yeah, go
from,
from
the
that
first
side
one
to
to the
the-
second.
No, you don't do that. You got to come up with something whose derivative you know is that.
Yeah, but how do you come
That's
up
what we're
with
doing.
that?
We're not doing nothing else.
How do you come up with that?
Yeah, how you do that?
Well, you know the derivative of the cosine has something to do with the sine. But the derivative of the cosine is negative, right? I don't want negative, so negative. By the chain rule, if you got cosine 3x here, you got sine 3x here, but you also got a 3 in front. That's why I needed the 2. You work backwards, right? Exactly. You start here. But that's not good enough, right? Because the derivative of cosine 3x is negative 3 cosine 3x. I want positive 6. Oh, okay. So fix it. Multiply by negative 2. It's like a fudge factor. Just fix it. That's all. Alrighty. So, we just did this, right? That's the exact same thing we just did. The answer to this last question is the answer to this new question. It's the same question. It's another way of writing the same thing. This big fancy S stands for an integral. AntiDifferentiate, that means in this case, right? And it's an S because it's a sum. We'll get to that. You ever hear of Riemann sums? We'll get to that. So, do you remember U sub?
Yes.
Let's not do it. Okay, this is how you do U sub. Ready? Now, who had the unnamed teacher last year?
Is that you?
I can't name myself. Her. Yeah, her. Who had her last year?
Besides me?
Oh, Cassie actually probably does it right. Hush! Okay. You had her? Okay, what? You probably do it all different.
I thought you were going to
Okay.
talk about this catch.
No, Cassie's
There's
top
no-
notch. No. So is, what's her name? Yeah, what? Huh? Yes. The answer is yes. Okay. How do you do U sub? Well, it's like chain rule backwards. Who's the stuff?
why is it 6 in front of the
Good. That was the question. I'm doing the same question.
Why is it 6 in front of the integral?
It could be inside or in front. It doesn't matter. Good, yeah. All right. So who's U? 3x. So what's the U dx? It's 3. What's the U by itself? 3dx. Okay. So how is this? Why is this called U substitution? Because wherever you see an x, you want to end up with a U. 3x is what? Is U. Okay, sine of U. Dx is what? Well, this says du dx. No, I don't want that. This says du. I don't want that. How do I get dx alone? Divide by 3. So replace dx with du over 3. And now do it.
Why is it a 2?
Because you just told me to put it over 3. I'm replacing dx with du divided by 3. Well, the 3 goes into the 6 2 times. You don't want to do that?
No,
Yes, we do want
I don't want
Uh,
We do want
how about that? Is that okay? Okay. All right. So the 3 into the 6 is 2. So I'm not doing that. And you know the antiderivative of sine. Negative cosine. Now that's where the 2 came from. You were asking where the 2 came from. That's where the negative came from. You're asking where the negative came from. But the problem started in terms of x. Can you name the answer in terms of x? Who's you?
How'd you end up making that 2?
Let's see. Is that the same answer we got? Yeah.
How did you...
Epsilon,
why
C,
did
same
you-
thing.
Why did you change that to a 2?
Why did I change that to a 2? Because we just said it's du over 3 times 6. I'm replacing dx with du over 3.
Why didn't you write that?
I did. I did, and then I just erased it. But you weren't looking, I guess.
Wait, why did you erase it?
Because you don't need to do that. Okay. That's why it's called U substitution, because there's no x's anywhere to be seen after that step where you replace the x's with u's. There should be no x's to be seen anywhere. I know other people do different, but that doesn't work too good sometimes.
I did it that way.
Okay. All right. Just saying. Okay. Huh? Where did the du go? We integrated. That's where the du goes. When I was in your chair. Let's see. Now I took AB calculus because we didn't have a BC teacher. We got to U sub near the end of the year. Let's say February, March, maybe March, and click. Everything just clicked right here. Everything just clicked. But it took little Garcia uphill both ways in the snow, barefoot with the slide rule on my back. Little red schoolhouse on the hill in Laurel, New York. For real, look it up. Laurel, New York, schoolhouse red. You can Google it probably. Okay, Google Images, your friend, right? Oh, it's probably blocked. Isn't it? On here? It's probably blocked for you guys. I can do it. Anyway. My teacher was a little cuckoo. You think I'm cuckoo? He used to call this deworming the worm. Deworming the worm. In other words, the integral and the differential are opposite operators. They cancel. They're gone. As soon as you do the integral, the dx or the du just goes away. Poof. It's an inverse operator. It cancels. All right? So the integral symbol and the du, they cancel. Right. We'll talk about why we multiply this times this later when we talk about Riemann sums being areas of rectangles, where this is the base and this is the height of each rectangle. We'll get to that. That's why we write it that way. It's a product. Right? Okay.
Let's do like 6 more.
Let's do like 600 more.
That might be it.
All right. All right, how about this? Here's something that's affectionately called a diffie-Q. A diffie-Q is an equation with a derivative in it. Ay, dang it, I can't write. And it might even be an initial value problem. Can you figure out the function we're talking about? All right, so I gave you the derivative of the function, and I gave you a point through which the function's graph goes.
What does that say? Level? LVP?
IVP, initial value problem. IVP, initial value problem, differential equation, okay? So differential equation is an equation with a derivative in it. The solution is the function whose derivative you're talking about. Can I figure out who y is?
Yes.
How?
Multiply by dx.
Before I anti-differentiate, I got to be able to deworm the worm. The d's cannot be in the denominator.
SDV. Yep.
That's right. Who says that? Is that a Heyonism?
Yeah.
What is it?
Separate the variables.
STV?
Yeah.
STV? Not to be confused with STV, right?
Yeah.
STV? All right. But I just did. All right. So how do you anti-differentiate 3x cubed? Well, we just asked that question a minute ago, didn't we? And you get what? You get x cubed plus a constant is y. Okay. What did we do? We
Wait,
just
why did you-
dewormed the worm on both
Why
sides.
did you change how you wrote it?
How do you change what?
Like, why did you change its name?
What name? The antiderivative of the derivative of y is y. These cancel. These operators are opposite operators.
Yeah,
They
but
cancel.
why did you get rid of the dx? Or you
I did. I
multiplied
just
it?
moved it up. I cross multiplied, basically. I moved it up. I just multiplied with dx on both sides. Because you can't integrate dy unless it's in the numerator. You can't integrate dx unless it's in the numerator. It's not a quotient. It's a product. Okay. Now, how do you resolve the plus c?
You need values.
I thought it was a laptop or something. Plug in. All right. So y is -1 when x is 1. And you figure out that c is, well, let's see, 1 cubed is 1. Subtracted, you get -2. So the final answer, Regis, this is the general solution to our diffie-Q. This is the particular solution that goes through that point I gave you. Okay? Alrighty, so that's solving differential equations using antiderivatives. Here's another one you might know. The acceleration due to gravity is
Wait, what? Can you go back to that? And what did you say IVP stands for?
initial value problem. They give you an initial value
Can you scroll down?
through which the curve. All right, so what is the acceleration due to gravity? I say it's 32. That's feet per second per second. Okay. And when you say 9.8, you're saying what units? Meters per second per second. And we're saying 5. You're not on the Earth. Okay. You might be on the moon or something, right? 5 watts. Feet per second per second? That's on the moon, by the way. You ever go to the Museum of Natural History? You ever walk around on the first floor of the planetarium? Did we talk about this? What? What's this?
You get your weight.
Your weight on the moon. Oh, your weight on Venus. God, I'm fat. Well, not that much. It's not that different. Right? Oh, your weight on Jupiter. Jeez. Right? The G is different on every planet. Why? It has to do with the mass, right?
Yeah.
But it also has to do with the distance from the center of the object, the center of the planet. So when we say it's negative 9.8 meters per second, that's when you're standing at sea level, like at Jones Beach. What if you're on Mount Everest? It's less. What if you're in Death Valley? It's more. So it's not always negative 9.8. It's a constant relative to where you are for small changes in delta y. Okay. All right, so why am I saying negative? Because the acceleration really is a vector. It has a direction too. The magnitude is 9.8. The direction is downward. It's based on the force due to gravity, ma or mg, right? Okay. Well, what's another way of saying acceleration? Isn't that the derivative of the velocity? So how about dv dt? All right, can you solve for v?
Yes.
All right, go ahead. Do the same thing we just did. What do you do with the dt? Move it over, okay. All right, then what? Anti-differentiate both sides. And you get v equals negative 9.8 t plus a constant. All right. Let's say I give you some initial values.
Why do you put the integral thing in the middle?
You can put it in front or behind the negative 9.8 is just a constant multiplier. It's a dilator, it doesn't matter really. Yeah.
Do we need the squiggly mark?
Which squiggly mark? Yeah, you should show what you're doing. Yes, this isn't Hayon's class. No. This isn't physics. What? Sorry. Sorry to pull rank. But I was a physics major too. At Cornell. Remember?
We get it.
All righty. So let's say, so I'm pulling rank on Hayon, and Hayon will acquiesce. What if I give you that the velocity at 5 seconds is negative 49 meters per second? Plug it in. Okay. All right. Well,
What did you say?
where did it go? Negative 49 meters per second at t equals 5. All right. So negative 49. All right. So how do you get c? C0, right? Because I picked that on purpose. Negative 9.8 times 5 is negative 49, by the way. So if you add it to both sides, c is 0. And so you get v as a function of time is negative 9.8 t. Okay. That's a t. But isn't the velocity in turn a derivative?
Yes.
It's a derivative of displacement. So how about we call that dSdt? Well, I'm going, let's say this is vertical displacement. How about dy dt? How do you get y? Your displacement curve. Multiply by the dt. And deworm the worm. All right, so you get y is negative 9.8 times t squared over 2, but half of 9.8, 4.9, plus some other constant. Well, that's confusing. I had a plus c before. How about we call it plus d? Because they're not the same necessarily, right? And to resolve the constant, I have to give you another initial position. How about you jumped from a 100-meter high cliff? Whoops. Or you tripped and fell off. Because your initial velocity, no, actually your initial velocity was negative 49 meters per second. You really wanted to commit harikari, didn't you? That's suicide in Japanese. Harakiri! No? When you talk Japanese, you gotta get mad. Harakiri! No? Hiroshima! No. Anyway. So, no, you didn't know that? It's just like German. Come and see here! Und get it! Yes, that one! Okay. All right. All right, so what am I plugging in for y to figure out d? Y is 100, t is 0, so d is 100, you're done.
Does it matter where the squiggly is?
What, you want to put it here?
Yeah.
You can.
Because you're multiple constant in front of it, so you could take out the
And that's a Galilean freefall model without regard to air resistance. If you're not going too fast or too far, that's correct, more or less. All right, so don't forget your homework. Page 294, multiples of 5. Thank you.
I had all my checks done in like the beginning of the course.
Yeah.
But it's my average.
You have to have a separate check every week. Separate check every week. At least 5 of them. You have 10 chances.
At least 5 years.
Yeah, at least 5 weeks worth. You have 10 weeks to get 5 weeks of hundreds. So show me some homework this week then. That's all.
Okay, can I make
Today? I mean,
like
tomorrow.
all of them like this week? Like if I do Wednesday, Thursday,
We'll try.
Friday?
Yeah. Try. How many are you behind? Do you remember?
I don't know because I had like 8 homework, 8 or 9 homework.
Yeah, but you gotta have it one a week. If you give me more than one a week, I'm just making sure you're getting the 100 that week, right? After the 5 weeks, if you don't have 500s, then you're trying to make up those hundreds. So.
Is there anything I can do to bring my grade up?
Well, I'm already doing the 5 points. That's all I can give. That's way
Make sure
more.
I'm failed.
Were you on the board?
And the multiple choices I got a 0.
Yeah. What the hell is that? How can you do that? Even guessing the odds are you're not going to get a good. Oh God. I don't know. I'll have to see. I can't give more points. I don't know. I'll have to see.
Is there any like work I should do?
The basic credit is 5 points. You can't do any more than that. In fact, I'm recording this, so I better stop. Bye bye, you.